So 6 mile radius, angle of 1 radian. What's the arc length that makes? Let's draw a picture of this. So let's make a big circle to start with. And center positive x-axis there. And that's going to be my radius equals 6. Now, just for fun, I want to draw in here. If that's 6, that's 3. 1 is probably right here. 2, 3, 4, 5, and 6 out there. So I'm going to draw another circle in here. So that circle right there has a radius of 1. Now, angle of 1 radian, what does that look like? Well, think about a radian talks about revolutions on a unit circle. And there are 2 pi radians in 1 revolution. Pi is about 3.14, so 2 pi is about 6.28. So there's a little more than 6.25 radians wrapping around this circle to get back to here. So if all the way around is a little more than 6, right, halfway around would be a little more than 3. So 1/3 of 3 is going to put me over here-ish. So my claim is that this angle right here, let's call it theta, is about 1 radian. Now, on a unit circle, the radian measure is the arc length, right? So this arc length right here on my radius 1 circle, it is also 1. So if that's 1 mile, then that arc length there is 1 mile. This circle, the big circle, is 6 times bigger. So the arc length is just 6 times that. So just a reminder, arc length, is always the radius as a multiplier times the angle, and that angle has to be in radians, doesn't work in degrees. This is the reason radians are so important right here. So in this case, I have 6 miles times 1 radian. Radian's kind of unitless, so this gives me an arc of 6 miles. So the arc length is 6 miles. 6 times 1 is 6. I wanted to give you a reminder about what radians mean.